So if you watched my last video on the creation of a route-based IPsec tunnel, you may remember this topology. So I've expanded the topology out a bit based on the customer's requirements, and that requirement was to leverage VDOMs. So I thought I would take this opportunity to take you through how VDOMs are created and how we can leverage them. So I've already created the constructs on the left-hand side, so I'm going to mirror that on the right-hand side and take you through that step by step. I'm not going to show you the stuff on the left-hand side because it's got customer-specific information. So we're going to start off with a completely clean profile on branch 2. So if we come across here, the first thing we need to do is to enable VDOMs. Now, on a physical FortiGate, if you scroll down the page, you will see this virtual domains. All right. Sometimes this is a virtual machine. Sometimes on virtual machines you may not see this option. All right. So if you don't see that option, obviously clicking that option is quite simple. If you don't see that option, you go config system settings, set VDOM mode. This has to be typed out completely because it doesn't have an autocomplete. The VDOM mode part doesn't anyway. And I put multi there. Sorry, wrong place. My apologies. Config system global. As I've always said in my videos, I don't hide my errors. I could tailor these videos and make them all crisp and clean with no errors, but that's not real world, right? I'm trying to show you the real world in the same way as if I was sitting right next to you helping you build a proof of concept, you would see exactly the same stuff. So set VDOM mode multi. All right, see no errors that time. Press end. It's going to log me out. Okay, it's logged me out. Now I'm going to go back in again. And now I'm in VDOM mode. So I know I'm in VDOM mode because it says they're global. All right, the global is where I configure all the fundamental constructs of the device in terms of the VDOMs and interface settings. The root VDOM is always there. That's what you would have on the FortiGate without any VDOMs. And obviously that is retained when you switch on VDOMs. So I'm going to create 2 more VDOMs. So I come along here under System VDOMs. I say create, and I'm going to just call them quite simply VDOM 1. Now, when I click OK, it's going to ask to take me to the interface side. Now, the reason it's doing this is because a VDOM is a complete carbon copy of the overall FortiGate. Right? So when you instantiate a VDOM, the VDOM loses no functionality over what the physical box can do. Right? So 100% of everything that you can do on the physical box in standalone mode, you can do in each and every VDOM. Now, a VDOM by itself is no good without interfaces, right? It's pointless having a firewall with no interface. So that's why it's asking me here to send me to the interface section so that I can actually map interfaces from the global pool of interfaces into the specific VDOM. Now, I'm not going to do that because for the purposes of this demo, I'm going to use a loopback. So I'm just going to come back here and I'm going to say VDOM 2. And we'll see that same message again, and I'm going to say no to that. So the root VDOM, as I said, is the default, hence why it says it's the management VDOM. And you can see here, here's the myriad of interfaces associated with that, which, as I said previously, I could have gone in and mapped some of these physical interfaces into each one of these individual VDOMs. But as I said, we're not going to do that. Now, in order for these VDOMs to communicate with each other, we obviously have 2 options. I could map physical interfaces and loop them back using external cables, but that's highly inefficient and quite ugly. Or I can create what's called an inter-VDOM link, and that's an internal link between VDOMs, and it can be between any VDOMs. Here I'm showing you these VDOMs 1 and 2 communicating with the root VDOM, but they could quite happily communicate with each other. It really doesn't matter. The fundamental thing to understand, though, is that There are two ways of creating VDOM links. Now, because this is a VM, I only have one option, which is a VDOM link there. But on a physical FortiGate appliance, you have an ASIC, what we call the NPU, Network Processing Unit. And that has a built-in Ethernet switch. And what that does is it enables you to create hardware-accelerated .1Q tags between VDOMs. And that is the preferred route because, as I mentioned, it's hardware accelerated, whereas this VDOM link will be a software instantiation, right? So clearly the hardware is going to have much greater performance. But on a VDOM, on a VM virtual machine, it makes no difference because we don't have that ASIC. And your lowest common denominator is going to be the number of resources that you've allocated to this host within your hypervisor. So now I'm going to go create VDOM links between the root VDOM and each one of those individual VDOMs that I've just created. So we'll call this VDOM 1-link. And I've got two options here, PPP or Ethernet. It doesn't really matter which one we use for the purposes of a virtual machine. So if it were the physical device, it would default to Ethernet. So I'm going to say, well, what is my source? So clearly there's got to be two ends to the connection, right? So the one end is going to be the root VDOM, and I'm going to give this an IP address 192.168.40.1/30, and the other side is going to be VDOM 1 and 192.168.40.2/30, and we'll enable ping on either side of those so that they can communicate. All right, so now I've created that first connection between the root and VDOM 1 link, VDOM 1. And now let's go do the same for VDOM 2. So we'll call it VDOM 2-link. And again, this is just a name. You can call it Bob, Mary, Donald Duck, whatever you want. It makes no difference. Whatever's meaningful to you. Root, and we'll call this 192.168.40.5/30. Ping there. And VDOM 2, 192.168.40.6/30. Ping. Okay, so again, now I can see I've got my VDOM 1 and VDOM 2 links there created. So now those VDOMs are no longer isolated. They can now communicate. Theoretically, clearly there's routing that needs to be done, but they can communicate northbound. Now, I'm just going to drop to the root VDOM because that was my original VDOM, and you can see that this has got an existing WAN connection, 2.6. And it can communicate up with this hub device here. So just to show that, I'm going to go execute ping 172.16.10.1, which is that hub device. Okay. And what we'll see just now is that once I've set up the routing within the VDOMs, they too will be able to reach out to this IP address via the root VDOM. So the first thing, in order to enable that, we're going to need a policy on that root VDOM. Otherwise, clearly, being a firewall, it's not going to pass any traffic. So, in fact, before I do that, I'm just going to do a little bit of cheating. I am going to use this thing called multiple interface policies, which enables me to use wildcards. And I would never recommend this in a real world. You want to specify your actual interfaces and your policies in a granular fashion, but this is purely for demonstration purposes. So outbound traffic, incoming interface, I'm going to put in these two links. Now, if I hadn't put in that multiple interface policy, I wouldn't be able to highlight these together. I would have had to have created individual policies, right? So those two going out to the wide area network, which is port 2. Close that. Source, we'll say any services all. Now again, in the real world, you'd want to tie these down. You don't want to put wildcards like this, but this is a contained environment. And I'm going to enable NAT. The reason I'm enabling NAT is because this is emulating the internet. So this router here is emulating the internet. And I remember I'm using RFC 1918 based addresses on these links, so the internet wouldn't have any view of those IP addresses because they're non-routable. And so if I tried to send the traffic over to the hub device using those RFC 1918 based addresses, the ISP's routers would just dump them And in this case, even though this is a contained environment, this hub has no route back to 192.168.40, the subnets. So what it'll see using the NAT is the egress IP address of this device here, and it'll respond back to that. So I've done that, I've created my policy. Okay, so I've got that in place now. And I'm going to switch off logging there. UTM means Unified Threat Mitigation. So it means only log any security events or matches. Now in this case, I'm not running any security features here, and I want to see all the traffic matches. So I'm just going to switch that on to all. Now you don't want to do that in the real world on multiple policies, because clearly that's going to be resource intensive. So be very careful how you use logging. So let's pop across to VDOM 1 now, and let's just check that we can ping the other side of that VDOM link. So so first of all, I can go diag IP address list pipe rep 40 dot, and that's going to show me all the IP addresses which have got 40 in it. All right, now even though this is a VDOM, I can still see all the other IP addresses from the global interface table, but it doesn't mean I can get to them, right? This is just purely for visibility. Now, what I can do here is execute ping 192.168.40.1, and I can see that I can get there. But if I try to ping 40.5, I can't get there, and I can't get to 40.6 because those belong to VDOM 2. Right, so the traffic is isolated, but at least I know I can ping across my own next hop, and that's all that really matters to me. Now what I'm going to do here is I am going to create a loopback interface, and we'll call this VDOM 1-loop, and we'll give this an IP address of, come back, it's a loopback, and we'll call this 11. Let's 10.4. Let's make 10.5.1.1 because I know I've used 4 elsewhere, /32, and we'll enable that to ping. All right, so now I've got a loopback interface, and we're going to use that as the source of our traffic. So now I need a policy to allow that traffic through. I need routing as well, but we'll start off with the policy. And I'm going to come along here, and I'm going to say, because remember, VDOM is a firewall in its own right. So again, we need policies to enable traffic to flow. So I'm going to say traffic to WAN. Incoming interface is going to be my loopback. My outgoing interface is going to be that VDOM link. Source all. Destination all, service all, close. Now I don't want NAT here, all right, because what I'm going to do is I'm going to enable routing so that the root VDOM can actually route. It's going to be able to see all the routes coming from these devices. So there's my policy there. Again, I'm going to change that logging to all. Okay. Now we need a route here, so what I'm going to do here is I'm going to create a static route. Now I could do OSPF, BGP, it doesn't matter. This is just for simplicity's purpose, and I'm going to say anything 192.168.40.1, which is my next hop, and it's going to automatically detect the interface, which you can see there. All right, but that's all well and good, but remember that the root VDOM doesn't know how to get back to my loopback, which is 10.5.1.1. So I need to go along here to root, create a static route, and say 10.5.1.1/32 is via 192.168.40.2, and again it automatically detects the link. All right, so now I've got a two-way communication there. So if I come to VDOM 1 now and I do a execute ping-options, and I set my source to 10.5.1.1, and I do an execute ping 192.168.40.1, I can ping quite happily, right? Because now the root VDOM knows how to get back there, which shows that I'm in a good place to start sending traffic to the outside world. So now I should be able to do execute ping 172.16.10.1, and there we go. It works fine. So now I am coming in from the VDOM that I've created. I know the route to the outside world is via that path. All right, so I've used that as my next hop. The traffic's going along here. The root VDOM is saying, well, how do I get to 172.16.10.1? It says it knows that from its own routing table that it's up there, and it's performing a NAT. So as far as the hub is concerned, the traffic hitting the hub is coming from the outside interface of this, and we see that happening quite merrily there. And I would do exactly the same on VDOM 2 to have traffic flowing from VDOM 2. Now, as I said previously, that was a loopback, but if, let's say, for example, I wanted to put a physical interface into those VDOMs, I would simply come across here within the global VDOM, and I would choose an interface. Let's choose interface 6, and I'll put that in VDOM there, and I'd give it a designation of LAN, for example. I don't have to give it an IP address at the moment. This is just to show you how you put the interfaces in the VDOMs. Come across to my VDOM, and now port 6 is there. It belongs to this VDOM, and it can't be used for anything else. Now, the last thing I would say is that the VDOMs are very, very flexible. So clearly what I've created here are default layer 3 VDOMs or root-based VDOMs. But the FortiGate supports transparent mode or layer 2 VDOMs as well, and it makes no difference. I can have one as transparent mode and another as L3, or I could have, you have a total of 10 VDOMs for free. Okay, no licenses, every single FortiGate bar. There are 1 or 2 exceptions on the lower end devices, but otherwise you get 10 VDOMs for free on the device. And you can use those 10 however you want. So if you wanted to have a transparent VDOM as a bump in the wire, you could do that. If I wanted to dedicate a VDOM just purely to sniffing traffic, I can do that as well. So let's say this was going to be my sniffer VDOM, and I wanted to take a span port off my campus network, and I wanted to span all the traffic from all the VDOMs into this FortiGate. I could simply switch that interface on one-arm sniffer mode, switch on all my layer 7 services here, and now I would get full visibility in terms of what east-west traffic is happening across the VLANs within that campus network, the sort of traffic that you would normally never see, because remember that your firewall doesn't see east-west traffic natively. It only sees north-south, i.e. the traffic that hits it. So this, for example, and as I said, is just another use case of a FortiGate, would enable you to gain greater visibility. Now, it's not just about creating visibility. I have created other videos before to show how the FortiGates can integrate with other parts of the Fortinet fabric. So in this case, any threats that this one-arm sniffer saw, it could interact with other components like FortiNAC, for example, to identify the rogue device that maybe has been picked up by the IPS sensor. It would signal the FortiNAC, and the FortiNAC would then take that device off the network. So, as I said, this is another use case of a VDOM, and don't just think because it's a sniffer that it's just idly, passively doing stuff. We can interact with the rest of the fabric to take remedial action against any threat. So hopefully that gives you a good overview of VDOMs, how simple they are to create, how efficient they are, how flexible they are, and yeah, they're free. So if you're a Fortinet customer, go ahead and enjoy. Thank you very much for spending this time with me. Bye-bye.